You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome to the MedX Podcast. I'm Steve Maxson. Today's discussion is focused on medical extrusion for medical devices, and our guest is Patrick Daly, Director of Extrusion at Biomerics. Biomerics is a fully integrated medical device contract manufacturer with a wide range of capabilities from pellets all the way to finished medical devices. Patrick, thanks for carving out some time to join us today.
Hey, Steve, thanks for having me. Very excited about doing this podcast. I've recently watched your previous ones and I really enjoyed them. So excited to be a part of it. Thank you very much.
Excellent. Thanks for that feedback. Patrick, before we get into some of the technical discussions about medical extrusion, please give an overview of your background.
Yes. So I started in medical extrusion about 15 years ago. Started as an operator working second shift, learning basic single lumen and some simple multi-lumen tubing profiles. And then I got into working as a technician. I moved my way up to that. And then after being a technician, I went to school on the side while working as an extrusion technician because I really enjoyed extrusion and I thought I could be successful in that field. And so I started learning more on the engineering side, tool design, process characterization. So I became an extrusion engineer, then an extrusion process engineer, a senior process extrusion engineer, and now I'm the director of extrusion here at Biomerics. Been with Biomerics for 7 years, and we are, like you said earlier, vertically integrated. We provide extrusions for our in-house production and research and development, as well as extrusions to the OEM manufacturing side.
Okay. I don't know if you had a chance to look at a recent article that NPO did where they had a roundtable discussion of various experts in medical extrusion, including a lot of my friends, frankly, Jonathan Gigadis at Spectrum Plastics, Tyler Ware from GenX, Gary Havrin from NDH Medical, and the great Tim Steele from Microspec. And one of the discussion points was, the challenges related to medtech extrusion and how to overcome them. And there was something that an individual said, Alex Kakad, from Technoplex. I hope I'm pronouncing his name correct, but he said something that really resonated me, and I'm going to quote it. He said, "More than anything, years of hands-on extrusion experience is the differentiating element to success." Right? So you can have the greatest state-of-the-art extrusion equipment, closed loop controls, quality system, clean room, but at the end of the day, right, you need people that are experienced with hands-on extrusion that can develop processes and train other extrusion operators.
I believe he's 100% right for what he was saying there. It does take experience on the line. I mean, like you said, you can have all the tooling, all the high-end downstream equipments, controlled loop, but if you don't know what you're doing and you don't know how to characterize the profile or do any of like the process characterization of the materials, your temperature settings, then you really won't be able to use all those tools that are helpful, especially for inline controls. So, and everyone that you mentioned, all those gentlemen that you talked about that were on that roundtable, I have the utmost respect for them. Those guys are the juggernauts of the industry.
Yeah, excellent. Thanks for your feedback there. Let's talk a little bit about multi-lumen extrusion. And as you see RFQs coming to your desk for extrusions for modern delivery systems used in structural heart, electrophysiology, surgical robotics, are you seeing an increased demand for complex multi-lumen tubing in profile shapes?
Yes, we are, especially in the robotic surgery field. We are getting many different profiles that I've not seen before. More challenges, thinner walls, more flexibility. They're looking for more flow channels. So we're seeing up to 25 lumens are coming down across our desks. We're also seeing different shapes that we have not seen, like I've said previously. But we are up to the challenges. We use, for multi-lumens, you have to have top shelf EDM wire technology if you're going to get the precise multi-lumen extrusions that are being required now in the industry. It's really gone from kind of basic multi-lumen setups, your double D profiles for your PIC lines, or the three lumen, the double D half shape, or you'll go from just the simple smiley face, I'll call it, you know what I'm saying, those profiles.
Yeah.
And people have done a lot of great things with those in the medical device industry, but now it's just more cutting edge. There's more challenges, especially in delivery systems. So we see more and more complex extrusions coming down our pipeline. A lot of them, I believe, are getting, companies are probably going out to multiple extrusion houses and just seeing who's quoting what or what's being done. And so right now, Biomerics is trying to, we're up to the challenge of most complex multi-lumens.
Wow, 25 lumens. Good for you.
We've done a 29 lumen bump tube. Pretty remarkable extrusion.
Let's talk about balloon tubing.
Sure.
Balloon forming. I recently had Teddy Mudge from Hoop Medical on the podcast, and Teddy's a fascinating individual. He was talking about medical balloons for medical devices, and one of the things that he said is, how challenging it is for him to get balloon tubing that meets his specs, that allows for high performance, repeatable balloon forming. Biomerics produces 20,000 balloons a week. Yeah. So I know that you know something about balloon tubing extrusion and balloon forming. One of the key parameters in balloon forming is the elongation of the extruded tubing. And as you know, elongation can be controlled during the extrusion process with temperatures, drawdown ratios, and the gap between the die face and the front of the tank. Share with our listeners the elongation property, what it is, why it's important to meet a certain elongation spec. Most importantly, how do you go about testing elongation through the process so that you ensure, a repeatable process and you can control lot to lot variation during the forming process?
Yeah, so balloon tubes are always going to be, they're complex extrusion, even if they are single lumen, because there's so much that goes into them. Concentricity is huge. You have to have 90% or better, or the balloon's not going to blow right or form right. So that's a big thing. And for elongation, we usually do, the specs are usually between 300 and 400%. And what that means is you take the tube off the line, you mark it at about, usually, it depends on the process, obviously, or it depends on the customer's requirements. But typically you'll mark it with a marker on a ruler and about an inch. And then you'll pull that through our in-house testing lab. We use a tensile tester for that. So it's not me pulling it and then somebody else pulling it. We'd have different variation there. So we use our in-house testing lab, which is state of the art in my opinion. And so we'll see, then we'll measure after it's pulled, we'll measure to see where the elongation is and what percentage it is at. And then we'll make adjustments on the line accordingly, especially like some of the options that you mentioned. Quench point is key, temperature profile, draw down, draw cone. So we'll make adjustments on the line as we do that. And we'll go back and retest until we get it. We have seen some successes recently in doing some annealing with some of the urethane balloons. So if we weren't able to get the elongation required, we would anneal them for maybe about 2 hours. And then we would test them again. And we actually had successful results on certain durometers, especially the 75Ds and the 65D polyurethanes.
Okay. Interesting. Biomerics is well known for your polyurethane solutions. You have your own polyurethane polymers, compounds, and I'm sure that you see requests for other grades of polyurethanes, Tecoflex and Pelethane. Let's talk a little bit about polyurethane compounds and functional additives. Beyond radiopaque fillers, are you seeing more demand for lubricious additives to lower the tack or the friction of tubing, and also heat and UV stabilizers?
We're seeing that a lot across the board, and not just on polyurethanes, but specifically polyurethane for this question. Yeah, we definitely see a lot of lubricious additives being requested. Heat and light stabilizers, that's always a bonus, in my opinion, to add to your material selection. But for urethanes, especially in the lower durometers, your 80As all the way probably to 55Ds, in that sort of durometer range. We're getting a lot of requests for adding some of the lubricious additives because there's these multi-lumen, these complex multi-lumens with 5, 6, 7 lumens down there, and they're trying to put fibers inside, the satellite lumens of the extrusion. And if you have a 55D polyurethane or a 90A polyurethane, you're going to have tack. It's just not going to go through there. So lubricity helps in that sense. So that we are seeing more and more lubricious additive requests in our materials.
Okay. And the heat and UV stabilizers, can you talk a little bit about that? I was in a meeting a couple of weeks ago in Minneapolis, and the gentleman showed me some P-bax tubing that was sitting on his windowsill over a time, and it just crumbled, right? That it has an impact on shelf life and storage. Talk a little bit about that.
I mean, big time. We've come a long way from just, putting tubing in black poly bags and storing them in a closet. Mm-hmm. The heat and light stabilizers that I've seen in the UV will help with shelf life, discoloration. That's the biggest one. If you have a natural P-bax and you leave it, like you said, somewhere where there is light, which is most labs, every lab, has lighting, and you'll see problems. You'll have discoloration. And with these heat and light stabilizers, you can have these extrusions last 3 to 4 times longer, in my opinion, that I've seen.
Okay, interesting. Earlier, we spoke about some of the extrusions that are required for structural heart applications and other modern delivery systems, steerable and deflectable delivery systems. For structural heart applications, we're often seeing a laser cut hypotube as the reinforcement in lieu of a braid reinforcement. And for those applications where you're using a laser cut hypotube, the outer jacket extrusions are used to encapsulate the cut pattern and provide a smooth surface on the OD. Are you still seeing a variable durometer jacket from proximal to distal, even when we're using a laser cut hypotube? Because the laser cut hypotube does all the work. So I'm wondering why you'd still see a multi-durometer jacket on a laser cut hypotube delivery system.
It's a great question. So we are seeing multiple durometers used on them. We do that here at Biomerics. And the reason is you have to marry the parts. So let's say some of that laser cut hypotube is really flexible, and part of the beginning of the hypotube is not as flexible. So you can't just throw an 80A polyurethane over the whole thing. So you're going to have issues, and you can't have anything too stiff over the flexible part, because then it won't do what it's supposed to do. So we are seeing definitely multi-durometers requested for that particular laser cut hypotube. Now, specifically backbone laser cut hypotubes, you have to have really tight segments. So you'll have your 55D, maybe that's an inch, and then you'll see 90A, 80A, all the way to, sometimes we'll even get to 60A with like a polyblend type mixture. Yeah. And you'll see these segments because it has to be so tight, because the tolerances are so tight, and it's a very intricate device.
Okay. For our common reflow materials, nylon 12, P-bax, TPU, I'm going to ask you some questions, and you just give me an answer to the first thing that comes to your mind. Okay.
That's fine. All right.
Metering screw, barrier screw.
Barrier. Depending on if you're doing polyurethanes. Now, some urethane screw designs, single flights will work, but barrier screws I've seen have a more steady output on most P-bax materials, most nylons as well.
Okay. Melt pump, no melt pump.
I feel melt pump can be a Band-Aid. So I think if you have your process dialed in and you have your right screw design, your right screw design, your right tooling, your correct head tooling, you should be able to get most extrusions. Now, is there a place for melt pumps? Absolutely. If you want super tight tolerances and you want to have really good control, and it's a production run and you want to keep this thing going all day, all night, I believe melt pumps are a great bonus to your line. I guess I'd put it that way. Yeah. We here at Biomerics, we do have them here. We use them when we need to use them. Probably about 90% of our extrusions are designed and process characterized with correct screw, and that comes from experience. And I've worked with some really great mentors in the past, Mike Ferrandino, Ken Cohen, those guys. They really taught me about screw design and tooling design for different applications. So yes, melt pumps are there for a reason. They're good to have, but do we use them all the time? I would say 90% of our extrusions are done without one.
Okay. Open water bath, vacuum tank.
Well, they both have their purposes. Free extrusion is always nice, with an open tank, but if your HDPs, your LDPs, even some of your larger durometer PBAXs, vacuum tank, non-contact and contact is the way to go if you're trying to get the best roundness, ovality. I recommend vacuum sizing.
US Extruders, others.
We do here at Biomerics. We do have one US extruder line, and we look forward to many more.
Excellent. Good answer, Patrick. Hey, it's been great having you on the podcast. We'll hope to get you back soon.
It's been wonderful. Thank you.
All right.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.